Welcome to the new section of this course, Linear Models, Logistic Regression. In this section, we will start with exploring various repositories and datasets, then logistic regression and confusion matrix. After that, varying the classification threshold in logistic regression. Post that, analysis and plotting an ROC curve without context. And finally, UCI breast cancer dataset. Now let's move on to the video, exploring various repositories and datasets. In this video, we will start with loading data from the UCI repository, then move on to viewing the Pima Indians diabetes dataset with pandas, and finally look at the UCI Pima Indians dataset webpage. Let's start with loading data from the UCI repository. The first dataset we will load is the Pima Indians diabetes dataset. This will require access to the internet. The dataset is available at UCI Machine Learning repository. This is the dataset which we will be using. So let's import pandas. Type the web location of the Pima Indians diabetes dataset as a string as shown here. This is the address which we will be using. Next, add the column names of the data in a list. After that, store the feature names as a list. Exclude the target column, the last column name in column names, because it is not a feature. Make a pandas data frame to store the input data. Use this command to do so. Next, we will look at viewing the Pima Indians diabetes dataset with pandas. You can view the data in various ways. Use this command to view the top of the data frame. Let's run it, and you should get the table similar to the one shown here. Nothing seems amiss here, except possibly insulin level of 0. Is this possible? What about the skin variable? Can that be 0? So get a rough overview of the data frame with the describe method. Run it and you will get the output like this. You can see the features plasma con, blood pressure, skin insulin, BMI have zeros as values. These values could be physically impossible. Make a note about additional zeros. Draw a histogram of the pregnancy X variable. Set the hist method variable bins equal to 50 for more bins and a higher resolution in the image. Otherwise, the image is hard to read. Let's run it. You can observe that it has been plotted. Now it's time to visualize the histogram. Before that, import the matplotlib.pyplot as plt. And then use plot.show command. Cool, here's the histogram which we expected. Following that, make histograms for all columns of the data frame. For that, run alldata.hist command. Change fig size within the method to the tuple 15, 9 and bins to 50 again, otherwise it is hard to read the image. You can see it's been plotted. With the help of plot.show, we will check out the histogram for better visualization. We will analyze the histogram. Blood pressure and BMI look like normal distributions, aside from the anomalous zeros. The pedigree function and plasma con variables are skewed normal, possibly log normal. The age and pregnancy X variables are decaying in some way. The insulin and skin variables look like they could be normally distributed, except for the many values of 0. Finally, note the class imbalance in the target variable. Re-examine that imbalance with the value count pandas series method. After running, you will get the output as highlighted here. There are more cases where the person is described by category 0 instead of category 1. Looking at the UCI Pima Indians dataset webpage. We did some exploratory analysis to get a rough understanding of the data. Now we will read the UCI Pima Indians dataset documentation. First, scroll down to the bottom of the page and look at their citation policy. Just click on Citation Policy. The diabetes dataset has the general UCI citation policy available here at this link. The general policy says that to publish material using the dataset, please cite the UCI repository. Finally, we will read about missing values and context. So let's go to the top of the page that has important links and an abstract of the dataset. The abstract mentions there are missing values in the dataset. Below the abstract, there is a description of the attributes. This is how I came up with the names for the columns at the beginning. What do the class variables mean anyway? What does the 0 or 1 mean in the target? To figure this out, click on the Dataset description link above the abstract. Scroll to point 9 on the page, which yields the desired information. This means that a 1 refers to a positive for diabetes. This is important information, and with regard to the data analysis, provides a context. Thus, we were right in suspecting some of the impossible zeros in the data exploration phase. Many datasets have corrupt or missing values. So here we have come to the end of this video.